Welcome back in lecture series on electrochemistry. In last video, we have studied introductory part of this topic. That is redox reaction. What is meant by redox reaction? Oxidation reaction, reduction reaction, and spontaneous and non-spontaneous reactions. And also how chemical energy is converted into electrical energy in dry cells, and what is meant by electrolysis and where the electrolysis process is used, that is in electro refining or in electroplating, how it is used, that part we have studied. Today in this lecture we will learn electric conduction. So let us see what is meant by electric conduction. The transfer of electric charge from one point to another point is called electric conduction. That is transfer of electron. It is a charged body. So transfer of electron from one point to other point, that is called as a electric conduction. And the substance that allows the flow of electricity, or that is flow of electron or charge transfer through them, they are called as conductors. That means this metallic wire, suppose this is the metallic wire, then this metallic wire act as a conductor. So substances that allows flow of electricity or charge transfer through them are called conductors. And these conductors are classified into two types according to the mechanism by which the transfer of electron or charge transfer takes place. And depending on that, conductors are classified as a metallic and electrolytic or ionic conductor. So let us see first what is meant by metallic conductor. Metallic conductors are also known as, or these are called as a electronic conductor. Metallic conductors are also called as a electronic conductor. And metallic conductor means a metallic substance which allows the flow of electron through them without undergoing any chemical change, that are called as a metallic conductors. Metallic conductor means metallic substances which allows the flow of electron through them without chemical change, that are called as metallic conductors. And examples of metallic conductors are silver, copper metal, iron, aluminium metal, tin. All these are the examples of the metallic conductor. And metallic conduction means what? It is a conduction of electricity that occurs by direct flow of electron under the influence of applied potential is known as metallic conduction. Remember that conduction of electricity, if it takes place by direct flow of electron under the influence of applied potential, then it is called as a metallic conduction. Now let us see how metallic conductors conduct electricity. You know that in solid state we have studied band theory, and band is nothing but a closely spaced energy levels. And according to this band theory, two types of bands are there. One is conduction band and another one is the valence band. And the band which has the highest energy, that is called as a conduction band. And band which has a low energy, that is called lowest energy, that is called as a valence band. In conduction band may be vacant or it may be partially filled and by the electrons. And in conduction band, electrons are free to move. These are mobile electrons. And these electrons in conduction band conduct the electricity. So see here this diagram so that you can understand the what is meant by conduction band and what is meant by valence band. You have studied already this part in solid state. So the band which has a high energy is called conduction band. Band which has low energy, that is called as a valence band. And conduction band may be vacant, or it may contain some number of electrons. It may be partially filled with electron, and the valence band is filled with the electrons, and these electrons are not mobile, and there is a gap, energy gap, between the valence band and conduction band, and this energy gap decides, the size of this energy gap decides whether the substance is insulator, semiconductor or conductor. In case of metal, this energy gap between conduction band and valence band is very less, or it does not exist. That means conduction band and valence band overlap, and therefore electrons from valence band can be promoted to conduction band, and those electrons which are present in the conduction band, they conduct the electricity. To understand this metallic conduction, consider here a metal sheet. This is a metal sheet, and you know that also you have studied in solid state, in metal crystal, metal positively charged metal ions that are called as a kernel or cores are present in a sea of mobile electron. These are the outermost electron of that metal atom, and these electrons are present in the conduction band and they are free to move. Free electrons, these are in outermost shell, they are free to move and they conduct the electricity. So the outermost electrons of metal form the conduction band, and in metal crystal, these electrons, mobile electrons, move in random direction, and therefore these free electrons do not conduct electricity, and therefore to conduct the electricity, this metal plate, we have to apply electric potential to this metal plate is connected to external battery, so that electrical potential is developed and electrons flow in a specific direction, and when direction is fixed, then electrons can flow. When direction of electron is not fixed, then current cannot pass or current cannot flow. But when the electron flow in a particular direction, current can flow. And to flow the electric current, this battery, this metal plate is connected to battery. And due to this, potential is developed and electron flow in a particular direction towards the positively charged plate and electric current flow. So electrons in conduction band are free to move and hence they flow under what? Influence of applied electrical potential. That is most important. Electrons flow under the influence of applied electrical potential in a particular direction. So like this, the metal conducts electricity. Now the conduction of electricity through the metal is due to what? Here, movement of electrons in the metal crystal. And there is no change in chemical properties of the conductor. Because of this movement of electron, there is no change in chemical property. And this flow of electricity does not involve any transfer of matter. Electrons have very small mass, that is 9.1 into 10 raised to minus 31 kg. So it has a negligible mass, and therefore the flow of electricity does not involve any transfer of matter. Matter is not transfer here. Mass is not transfer here. And the conduction decreases If you increase the temperature, then conduction decreases because the positively metal ions which are present in the metal crystal, they vibrate, and due to this vibration, when temperature is increased, this vibration increases, and this vibration resists the flow of electron. So conduction decreases with increase in temperature. Remember that conduction decreases with increase in temperature. So this is about metallic conduction. Here see, it is a cold wire and it is a hot wire. And these wires are connected to battery. When electric current flows through cold wire, then the conduction is more. And when it is passes, electric current flows through the hot wire, then see here the conduction is slow. That means conduction decreases with increase in temperature. When you increase the temperature, the abstractions, that is these metal ions, resist the flow of electron. And here the resistance of the metal ions, positively charged ion, is less, and therefore conduction is more as compared to hot wire. Then the second point, that is electrolytic or ionic conduction. Now, electrolytic or ionic conduction means conduction that takes place by movement or migration of positive and negative ions of electrolytes. Electrolytes means those substances which flows the electricity through them, that are called as electrolytes, such as strong electrolytes such as HCl, NaCl, that means molten ionic salts. They can act as an electrolyte. Strong acids, strong bases, weak acid, weak bases, all these can act as electrolytes. So those substances which conduct electricity, they are called as electrolyte by breaking the ions, breaking down the ions, that we have studied in ionic equilibria topic. So here it is a electrolyte, and when electricity is passed through, the electrolyte tank is there, and in that the graphite rod or platinum rod are immersed, as they are inert. They do not react with the electrolyte, and in electrolyte positive and negative ions are there. Suppose this is the sodium, molten sodium chloride, then these red circles represent sodium ions, and these yellow circles represent the chloride ions. They are present in the electrolyte solution. And when electricity is passed through them, then what happens? The electron, this negatively charged chloride ion, move towards the positively charged anode. And here this is the negatively charged chloride ion, and they move towards this anode and they get discharged, and and forms a chlorine atom, unstable, and two such unstable chlorine atom combine and form chlorine molecule, and the electron lost by this chlorine, they passes through this battery into here, that is at cathode, and sodium ions already are present in the electrolyte solution. They accept that electron and get deposited on the cathode. So like this, the electrolysis is the electrolysis process. So like this, electrolysis takes place, and these electrolyte conduct the electricity by the movement of positive and negative ions of electrolytes. So charge transfer, positive or negative ions, that is charge transfer, occur in the form of movement of ions through the molten or aqueous solutions of electrolyte in electrolytic solution, or it is also called as ionic conduction. This type of conduction is also called as ionic conduction, and through which it takes place, that is called as electrolyte. And the examples of this are solutions of ionic salt, strong and weak acids and bases. These are the examples of electrolytes. So ionic salt dissociate into ions when dissolved in a polar solvent and in a molten state like this. Suppose this is the same example. It is a molten sodium chloride and chloride ions. They get discharged at this positively charged electrode, and these electrons are transferred through this. They flow in this direction, and here the sodium ion accept this electron and get deposited on this cathode. Negatively charged electrode is called as an anode, and here it is called as a cathode. So at cathode sodium get deposited, and at anode chlorine liberated during what? The electrolysis of molten sodium chloride. It's an example of the electrolysis. So electrolytic conduction involves transfer of matter. See here, sodium ions move towards negatively charged electrode, and chloride ions move towards the positively charged electrode. That means transfer of matter, that is electrolyte, from one part to another part takes place in the electrolytic conduction. That means a chemical dissociation of sodium chloride takes place. That means chemical change takes place during electrolytic conduction or ionic conduction, and it increases with increase in temperature. What happens here? Whenever the temperature is increased, then the bond between the sodium ion and chloride ion becomes weak, and more sodium ion and chloride ions are available for conduction. And sodium, you know that sodium chloride is a strong electrolyte, so it undergo 100% dissociation. And as temperature increases, the bond between these two, that is sodium and chlorine, becomes weak, and therefore the conduction increases. But whenever weak electrolyte is there, such as acetic acid is there, then the conductance increases due to increase in degree of dissociation, or degree of ionization is increased. In case of the weak electrolyte, degree of dissociation is less. They do not undergo 100% ionization. But when temperature is increased, the ionization increase. And due to increase in the ionization, in case of weak electrolytes also, with increase in temperature, the conduction increases. On that basis of conductivity, electrolytes are actually classified into three types. All this part we have studied in ionic equilibria. That is, those substances which do not conduct electricity, they are called as a non-electrolytes, such as ethanol, then sugar, urea. These solutions are called as a non-electrolyte. And those which conduct electricity or 100% get dissociated, they are called as, they have high conductivity and they are strong electrolytes. And those which conduct electricity, that is low conductivity is there, that are called as a weak electrolytes. So non-electrolytes examples are sugar, urea, alcohol. Strong electrolytes, you know, KCl, that is salt, NaCl, KCl, HCl, NaOH. These are examples of strong electrolyte. And weak electrolytes means acetic acid, NH4OH. These are the solutions of these substances are examples of weak electrolyte. And on the basis of conductivity, these are classified into these three types. Those which do not conduct, they are called as or which have no conductivity, they are called as a non-electrolyte, and they have conductivity nearly equal to water. You know that water is a poor conductor of electricity. It conducts a very less, that means its dissociation is very less. So here the sugar and urea or alcohol, they have same conductivity as that of the water, and therefore these are included in non-electrolytes, whereas the KCl, NaCl, HCl, NaOH, they conduct electricity. High conductivity is there because their dissociation is 100%, and here as compared to this, they have low conductivity because their dissociation is weak, or as these are weak electrolyte, they conduct low conductivity but higher than water. So such a substances, electrolytes, are called as a weak electrolyte. Solutions of acetic acid or any other weak electrolyte, that is NH4OH, These are the examples of weak electrolyte. So let us see the difference between metallic conduction and electrolytic conduction. So now you know that here we have studied metallic conduction is due to flow of electron and electrolytic conduction is due to flow of ions, positively charged ions or negatively charged ions. Metallic conduction involves no change in chemical properties. It is a physical change. But electrolytic or ionic conduction, it is chemical reaction takes place. Dissociation of the electrolyte takes place. That means chemical reaction takes place at the electrode. That is negatively charged and move towards the positively charged plate or electrode, and here they get discharged, or positively charged ion goes towards or move towards the negatively charged electrode and get deposited. That means what? It involves a chemical reaction at the electrode. So it is a physical as well as it is a chemical change. Remember here this point. Then third, that is, it does not involve transfer of matter, because here electrons are transfer, flow of electron is there. Metallic conduction is due to direct flow of electron, and electrons have very small mass, that is 9.1 into 10 raised to minus 31 kg, and therefore it does not involve any transfer of matter, but it involves the transfer of matter in the form of ions. You know that sodium has mass 23 and chlorine has 35.5. So it involves the transfer of matter, transfer of mass takes place in the form of ions. And fourth point that is important, that is conductivity decreases with increase in temperature. And in case of electrolytic or ionic conduction, conductivity increases with increase in temperature. So I hope that you understood metallic conduction, electrolytic conduction or ionic conduction and the difference between these two. So thank you.